So when we talk about end behavior, we're talking about the left side and the right side arrow. Okay, like for example, we're going to look at this graph right... Oh, stinky. Okay, we're going to look at this graph right here. Okay, there's a left side and there's a right side. So, let's write that down. So end behavior. That's what we're talking about. End behavior. You're going to like this because it's not like too strenuous on the brain. It's just the vocabulary. Okay, so this is obviously the left side arrow and that's the right side arrow. Right? Hey guys, what's the left side end behavior? Where's the arrow pointing? Up or down? And what's the right side? Down. Okay, pretty simple, right? Okay, but now we got to make it a little bit more mathy. All right, so what are we talking about when we're talking about the left side? We're talking about when the x's are approaching negative infinity. The right side is when x's are approaching positive infinity. Okay, so I'm going to write that out. This is some vocabulary terms for you. If you see x approaching negative infinity, this means left side. If you see x approaching positive infinity, this means right side. So that's how we describe the left side and right side. We talk about the x's because x's go left and right. Does that make sense? Okay, and then how do we say up and down? More mathy. Instead of just saying up or down, what are we going to say? Okay, which axis goes up and down?
Y.
The y's. Okay, now we can use y's or we can use f of x because whenever f of x is used, that's the same as y, right? Okay, so I'm going to say f of x approaches positive infinity, f of x approaches negative infinity. Which one of these says up? The first one. This one says up. The next one says down. So you have to use a combination of these to describe end behavior. All right? So this is how I describe end behavior for this dude. If I was asked to describe end behavior for this guy, I would say as x approaches negative infinity, f of x approaches, what would you say? Infinity. The left side of the graph goes up. That's what it says. As x approaches positive infinity, f of x approaches negative infinity. And that's for this graph right here. As I go to the right side of the graph, the function points down. Okay? You guys understand the end behavior? Alright, so let's try another one. Let's try this red one right here. Let's do the end behavior for this red one. As x approaches negative infinity, and as x approaches positive infinity. We want to talk about both sides, the left side and the right side. Okay, so what is f of x doing as we approach negative infinity? Look at the arrow. Where's it going? Oh, up. So we're going to say positive infinity. What is f of x doing as we approach positive infinity? So as I'm going to the right, what is this graph doing? It's pointing up. So infinity. So this one, both the end behaviors are pointing in the same direction. In fact, that would be true for all even functions. Are you guys with me? Yeah. All right, so I'm going to give you guys a quick little table that you guys can remember if you are practicing with end behavior. Otherwise, I think you guys got this. Here, let's do our table. This is what the table looks like. You can put the degree on top or the side. I'm going to put degree on the side. And this is going to be leading. Actually, I should just write out leading coefficient. Leading coefficient. Okay, we have only looked at, actually no, we've looked at negative ones too. Okay, so positive leading coefficient, negative leading coefficient. I don't know if you want to do the plus. Maybe you want to write positive just because it kind of looks like these inside here. Okay, for degree, we have even and we have odd. Okay, even degrees, the graph is going to point the same direction on both the left and the right side. And so I like to write like this. Up, up, or down, down. And I just put corners there so I know that the graph is going to point up, up, or it's going to point down, down. So this is when it goes down, down when the leading coefficient is negative. It goes up, up when the leading coefficient is positive. For example, x squared. What does that one look like? Both pointing up, right? What if the leading coefficient was negative? then that means both pointing down. All right. Now, it wouldn't matter much if you have other things going on here. Let's say you have 5x and then we have plus 6. That just means, okay, we're going to go through -2 and -3 when we factor it. It's going to go like this if we have a positive leading coefficient. But if we have a negative leading coefficient, that's going to make the graph go down. All right, so leading coefficient's all that matters when you're trying to decide if you're going to go up, up, or down, down. Now look at the odd. For odd functions, you're going to go down, up for a positive leading coefficient, or you're going to go up, down for a negative leading coefficient.